Okay, so I'm going to do a quick video here on using confidence intervals as a form of hypothesis testing. And I'm not big into using this method. It's okay if it's a two-tailed test like this one or a two-sided test where your alternative is not equal to. Then to me it's valid. You can see it makes sense. Your book is going to have you do some one-sided tests where this is less than or greater than. I'm not as enamored with that, but I'll show you how to do it. Quick example, we're just going to have simple hypotheses. The mean is 100, is what our null is, alternative not equal to. We're going to do a 5% alpha level. So we used alpha with confidence intervals to begin with. And if you remember, 100 minus the alpha gave you your confidence interval level. So in this case, I'm going to have a 95% confidence interval. I have some sample or summary stats here, a sample mean of 98, a standard deviation population of 14. Right there, that's telling me I'm probably using a one sample Z. Sample size is 12. I went into StatCrunch and I found a 95% confidence interval using a one sample Z procedure. And I came up with it here. You should pause this and go do it yourself. Make sure you get the same numbers. But this interpreted. My lower limit is like 90.08. My upper limit's 105.92. And I want to compare that to my null hypothesis, which is I'm testing, is the mean equal to 100? Well, it's very simple. Is 100 between 90 and 105? Yes. So if it's in the interval, you're going to fail to reject. Okay? I don't have evidence to say that the mean is not 100 if my confidence interval is bounding 100. If 100 had not been in the interval, then I would have rejected it null. So it's a pretty black and white test, but it doesn't have a test stat, it doesn't have a p-value. Okay? And when I test you, I'm going to be asking for those things. Okay, so here's another one. One-sided test. We're going to do a one-sample proportion here. P is equal to 0.56. P is less than 0.56, so a lower-tailed or one-sided test. I had 75 successes out of 200, and I want to test if that gives me sufficient evidence to reject the null. So the difference here is I'm going to pick an alpha of 3%, and alpha can be whatever, but I'm picking 3. Typically, we would do 100 minus 3 and get 97, but not on a one-sided test. You have to subtract 2 times the alpha. So in this case, 100 minus 2 times 3, or 100 minus 6, will give me a 94% confidence interval. So when I go in StatCrunch, and again, same thing, you should go and do it too, I get my interval to be like 0.31 to almost 44. My null was the proportion is 0.56. 0.56 isn't anywhere close to being in there. So that's telling me I have evidence to reject a null in favor of the alternative. So you're going to have some homework problems that are going to make you do this. I can't get them out of the program. Sorry, because they're multiple part problems. But you can deal with it. Okay?